All right, I'm going to go over a couple proofs from the two worksheets. I know this is a little bit late, but I haven't had time to do it, so I apologize for that. Off worksheet number 1, I got a question on problem number 5, so I'm just going to go through the whole problem. So this is what we're trying to prove right here, and I'm probably going to start on the left side, so left side. And when I look at this thing, I see that on the right side, I want the tangent of 3 theta. So I notice that that angle is 3 theta. And here, I notice that I have 3 theta right there. So while it's tempting to actually apply the sine plus sine identity and the cosine plus cosine identity to those two terms, that's going to get rid of the 3 theta. I don't really want to do that. So I'm going to rearrange these terms like this. That's 3 theta. So this is cosine theta plus cosine 5 theta plus cosine of 3 theta. So now I'm going to apply the sum product identities on those two things. Okay, so I'm going to apply the sine plus sine identity to this, the top here. So this is 2 times sine of half the sum, and I'll go ahead and just write that. Okay, and then times the cosine of half the difference. Okay, I'm writing this half the difference out just so that you can see it. Okay, and that sine 3 theta is still there. Sorry, and that's a plus sine 3 theta. Okay, on the bottom, I'm going to apply the cosine plus cosine identity. So this is 2 times the cosine of half the sum times the cosine of half the difference. All right, so I have that step. Now, I'm going to go ahead and just do these things. All right, so I'll do that in blue. So this is 2 times half the sum is sine of 3 theta. That seems to be a good thing. Times, not plus, times the cosine. This is negative 2 theta plus the sine of 3 theta. Still there. Okay, so we have 2 times the cosine of 3 theta on the bottom times the cosine of negative 2 theta plus the sine of 3 theta. All right, now, it may be problematic. It seems like that we have negative 2 theta. But what I want you to realize, first of all, is it doesn't matter whether it's cosine of 2 theta or cosine of the opposite of 2 theta because cosine is even. And we also don't even need to simplify because if I'm looking at the top and the bottom here, I'm looking to factor. And I see that the common factor on the top is sine 3 theta, and the common factor on the bottom is, well, what did I mess up on? All right, and I've caught a mistake that I made when I was rewriting the second step, and then this here too. This should have been, it was always cosine of 3 theta. That's why I was temporarily confused as to what was going on, because I was trying to point out that there was a common factor on the bottom, but there wasn't because I miswrote what I had before. Okay, so factor out of the top a sine of 3 theta. I am left with 2 cosine of the opposite of 2 theta plus 1. And on the bottom, I'm left with the cosine of 3 theta times, well, look at this. Again, I get 2 cosine of the opposite of 2 theta plus 1. Okay, these things cancel, they divide out, and I am left with the sine of 3 theta over the cosine of 3 theta, which is exactly what I want. It's tangent of 3 theta, which is equal to the right. So we've proven it. The second problem I'm going to go over is from the second worksheet. It's number 3, which looks like this. Okay, and so when I'm looking at it, first of all, I miswrote it. This is a plus here. when I'm looking at it, I see a cosine plus a cosine on the top, and I see that the angles are 2x and 2y, and so I don't like that. I'd like to do something with that. Okay, now I have an option here of applying the identity for the cosine plus the cosine, but I also have the option of simply applying the cosine double angle identities up here. Okay, so let's do that. Now, when I apply those identities, I know that I have lots of options of how to do it. So I'm going to do it like this. Well, I'll just do it like this. Cosine squared of x minus sine squared x plus cosine squared y minus sine squared y. Okay, and if I look at that, it's like, well, what's going to happen? I can't really do too much. So I'm going to try it a different way. I'm going to maybe do, let's see. How about this? Let's do 1 minus 2 sine squared x plus, it'd be great if I could get a negative 1 here. How about, so then I'll do 2 cosine squared y minus 1. Now I see this 1 and this negative 1 will cancel. Alright, so this and this go away. And so I'm left with negative 2 sine squared x plus 2 cosine squared y. Okay, and that seems a little bit weird. So let me change the way I write this. How about 2 cosine squared y minus 2 sine squared x? And then I have sine x plus cosine x here. All right, now I see I can factor a 2 out from the top. Okay, making sure I'm keeping track of my x's and y's, which I've already screwed up here. That's a y. That's a y. All right, now I see that this is the difference of squares. So this is 2 cosine y minus sine x and cosine y plus sine x. This is sine x plus cosine y. I'm going to write it as cosine y plus sine x. So this will help me see that this and this are the same. So those can divide out. And I'm left with now 2. Let's see what we want. Well, look, that's what we want. We want this, and that's what we have. We're left with this thing, which is 2 cosine y minus 2 sine x. It's equal to the right side. 2 pretty good proofs to understand. I hope that me making this video, helped clarify some of the steps that I did in the solutions. Thank you.